Verifying trigonometric identities is the process of proving that the left-hand side of the equation is equal to the right-hand side. There are many ways you can go about verifying trig identities, but there are some guidelines for proving trig identities that can help start you off, especially when you don't know where you're going to at the beginning. First, start with one side, meaning pick one side of the equation and write it down. You are trying to transform it into the other side. Now, which side should you choose? It seems counterintuitive, but you should always start with the more complicated side. The more complicated it is, the more you can do. The more you can do, the more options you have. The simpler side you choose, the less you can do because you have less options. So it's counterintuitive, but always start with the more complicated side. 2. Use known identities. Use algebra and the identities that you know to change the side you started with. So start manipulating it algebraically, trigonometrically, start trying to manipulate to where it gets to be the same as the other side of the equation. And third, and probably the most important, convert to sines and cosines. If you get stuck, try to rewrite all functions in terms of sines and cosines. I like to start off normally with sines and cosines, but you can do whatever you feel is the best path. Just remember, there's not one path to succeeding or proving it or verifying it. There are multiple paths. So let's start off with a nice, easy example. Sine theta over tangent theta equals cosine. So first off is I'm going to start off with the more complicated side, sine over tangent. So I'm going to write that down. So sine theta over tangent theta. And I'm going to use the fact that I know that tangent is just sine over cosine, just changing it into sines and cosines. So sine theta over sine theta over cosine theta. Remember, sine over cosine. Now this is a fraction within a fraction, so I'm going to change it and flip it around so I can simplify it easier. So sine theta over 1 times, and then sine over cosine gets flipped, cosine theta over sine theta. The sine thetas cancel out from here, leaving you only with cosine theta. Well, cosine theta equals cosine theta, so you have verified that sine theta over tangent theta equals cosine theta. Now again, that was a nice easy one. Nice way to start it off, but let's do one that's a little bit more involved. Cosine v over secant v sine v equals cosecant v minus sine v. A lot of stuff going on here. How would I even approach this? Well, there's a couple of different ways, but again, I'm going to start off with the more complicated side, which is, in this case, the left-hand side. So cosine v over secant v times sine v. And I'm going to change secant to its cosine version, 1 over cosine. So I'm going to have cosine v over 1 over cosine v times sine v over 1, just to keep it as a fraction. And I can just multiply the fractions in the bottom together, so I'm going to have cosine v over sine v over cosine v. And again, I'm going to flip it and multiply, and I'm going to end up getting cosine v over 1 times cosine v over sine v. And I'm going to move it down here. I can't cancel anything out, but I can multiply the cosines together. So I'm going to get cosine squared v over sine v. Now, it doesn't seem like there's much you can do here, but there is something. One of the more important trig identities you need to know is that sine squared plus cosine squared equals 1. This is a very important one that you need to memorize and know because it comes up quite often in trigonometry. And you can algebraically manipulate it. I can subtract the sine squared over and get cosine squared equals 1 minus sine squared, which is what I'm going to do. And when I do that, I'm going to end up with 1 minus sine squared v over sine v. Again, because they are equal to each other. If I just subtract the sine squared over, cosine squared equals that, so I can substitute it out. And now I can split the fraction apart. I can do 1 over sine v minus sine squared v over sine v. 1 over sine v is just cosecant v. And then sine squared over sine, one sine cancels out each, leaving me with just sine v, which is exactly what the right-hand side says. Very simple, very easy. Proves that it's true. But you need to remember that this formula up here, sine squared plus cosine squared equal 1, probably the more important one to remember because it will come up fairly often. Doesn't mean it's the only one that comes up, but it comes up so frequently that you really need to memorize that.